So now, guys, let's talk about lithium-ion batteries, the most common type of batteries used in electrical vehicles. This is the most common chemistry that we are gonna find in electrical vehicles. Let's discover why. Okay, talking about the advantages and disadvantages of these lithium-ion batteries. Okay. So, lithium-ion batteries are used in electrical vehicles because they have many advantages compared to the older battery types. In other words, the older chemistry that like lead acid, for example, or nickel-based batteries. Okay. The first advantages that we are gonna find is the high energy density. Okay, so what does it mean? That they can store a lot of energy in a small and lightweight package. Okay, then we have a high voltage. Okay, we have also very high voltage compared the other chemistry. Also, they have the reduced self-discharge is they have the slow self-discharge compared to the other chemistries, and then a long life. Okay, why we say that they have long life? Because they have long cycle life. They last thousands of charge cycles, meaning they don't need to be replaced often. Okay. Also, the high voltage is very useful for the fast charging. They can charge much faster than older battery types. Okay, the power that they can receive is very high. Okay, so not memory effect. This is another advantage compared to the past chemistries. I don't know if you listen about the memory effect. Uh, but these lithium-ion batteries don't need the memory effect. Okay, unlikely older batteries, they don't lose capacity if charged before being fully empty. Okay, uh, then then let's talk about the disadvantages. Okay, so the lithium-ion batteries needs continuous supervision of VMS. Okay, in a vehicle, as I said before, the BMS is the battery management system. That is the control unit of the ion lithium batteries inside the electric vehicles in order to control the temperature and the voltage levels. Okay, it's very important to have the lithium-ion batteries in the safety area. Then we are going to talk about this upper and lower voltage limits. Also, current limits, and also the lithium-ion batteries are thermal instability. Temperature and C rates accelerate the battery aging. Okay, so in the safety risk, if damaged or overheated, they can catch fire. Okay, then in the next slide, we're gonna talk about the thermal runaway. Don't worry about this. Then the limited raw materials. Also, the lithium, cobalt, and nickel are very expensive and difficult to mine. So it means that these kind of batteries are gonna be very expensive. Okay. The degradation over the time, batteries slowly lose capacity after many charge cycles. So as every battery in with different chemistries also have aging. Okay. And also the sensitive to temperature, no, extreme heat or cold can reduce performance and lifespan. Okay, so lithium-ion batteries are great because they are lightweight, last long, and charge fast. But they also have challenges like high cost and aging over the time. Okay, Despite their disadvantages, lithium-ion batteries are the best option for electrical vehicles today. However, researchers are working on new technologies to make them even better. All right, now we are going to talk about something very, very important and sometimes dangerous when it comes to batteries. It calls the thermal runaway. Okay, as you can see, there are a lot of fumes or fire. Don't worry, it sounds complicated, but I'll explain in step by step in a way that easy to understand. Okay, what is the thermal runaway? Let's imagine a battery gets too hot. Maybe it was charged to wrong way, maybe it was damaged, or maybe it was squeezed in an accident. Okay. When this happens, sometimes a scary can start. The battery begins to heat itself up more and more and more, like a snowball rolling down a hill and getting bigger. This is what we can call thermal runaway. It's when the battery heats up, and that heat causes it to heat up every more, again and again until it catch fire or explode. Okay. So why does it happen? Inside the battery we have the chemistry. No, there are chemicals. Okay, these chemicals are safe. Okay, are very safe. The lithium-ion batteries, but only if you operate this in this safety area of temperature. Okay, um, these chemicals are safe as long as the battery stays cold and healthy. But if the temperature goes too high, the materials inside can break down. Okay, the electrolyte can be damaged. So that's the starting of the thermal runaway. The battery can release flammable gases that can catch fire. Okay, and then if there are a spark, boom, the gas can ignite. Okay, it's like if you share a soda bottle really hard and then open it. Everything inside burns out. Okay, but in this case, it heats and gas, no soda. Okay, guys, because what can cause this thermal runaway? First of all, overheating. Okay, then the overcharging also. Also, the short circuits, guys. Short circuits, if you connect the positive and negative, it's a short circuit. It could happen at thermal runaway. Okay? Physical damage, like if the battery is punched, crushed, or dropped. Okay? Dropped hard. And also the very high temperatures, as I say, leaving a battery in the hot zone or near a heater. Okay? So the thermal runaway is it happens in one cell. Okay, then we have the propagation effects. So the propagation effects is when all battery packs start to burn. Okay, how can we stay safe? Now the good news, the thermal runaway is very rare. Okay, and we can avoid it by being careful. Here's some simple safety tips. Never use a damaged battery or damaged cell. Okay, if it bloated, cracked, or smell weird, don't use it. Okay, don't overcharge and also don't over discharge the cells. Okay, always use the correct charger and unplug when it's full. Okay, keep battery cool. Don't leave them in hot cars or hot spots. Okay, and also don't don't short circuit the battery. Okay, Mm, thermal runaway is very dangerous, yes, but if we treat batteries with care, it won't happen. Batteries are amazing tools that they can supply energy to our electric vehicle, but just to need use it with responsibility. Okay, respect the battery and it will work safely for you. Okay, here guys we can see the difference of the energy density between all the chemistries that we have. In orange, we can find the different ion lithium batteries that we have on the market. Okay, so lithium-ion batteries uh, have the biggest energy density compared the other different chemistry of batteries. Lithium-ion batteries in the anode we can find graphite. Okay, and the cell voltage depends of the cathode on the cathode's chemistry. Okay, so let's pass to the next slides to see this kind of chemistry that we can find on the market. Now let's see the different kind of lithium-ion batteries that we can find on the market. Okay, depends of the cathode chemistry. We can find the lithium titanate, lithium iron phosphate, lithium manganese oxide, lithium nickel manganese cobalt oxide, lithium cobalt oxide, and finally the lithium nickel cobalt aluminum oxide. Okay, so then we can see that every kind of chemistry have different range of voltage. For example, the most the chemistry that has the biggest one is this one, no? Lithium nickel manganese cobalt oxide. Okay. Also, the nominal voltage, as you can see, it's varied depending of the chemistry of the cathode. Okay. Uh, the thermal runaway value of temperature it's gonna change. As you can see, the temperature in order to has a thermal runaway is very high. So if for example in a lithium iron phosphate you can support 270 degrees of temperature in order to pass a thermal runaway. So the ion lithium batteries are very safe if you control the temperature of the chemistry. Okay. Also, you can see the different life cycles that they can support. Uh, it's very different. For example, the lithium nickel cobalt aluminum oxides only have 500 cycles. So after 500 cycles, the battery, the aging is gonna damage very hard the battery. For example, let's see another example, the lithium nickel manganese cobalt oxide. It has between 100 to 1000 to 2000 cycles, no? And finally, the power capacity of the maximum C rate that they can support, it's gonna change, no? For example, the LTO only support 10 C rates, that is a lot. But for example, if we see the lithium cobalt oxide only support 1 C rate. So what does it mean? For example, these two ones is not gonna support fast charging because their their chemistry only support very low power, no? Compared to this other chemistry that support 10 C rays, 10 C rays, 25 C rays for lithium iron phosphate. So if you ask which one is the best, it's gonna depend of the purpose of your vehicle. For example, if you have a hybrid vehicle, you don't need fast charging in hybrid vehicles. So these two could be good options. Okay. Also because it has very good value of voltage, the cycles are good also, and because, as I say, the depth of discharge of the hybrid vehicles are very small, because you pass from the 60 state of charge to the 40% of state of charge. So it's also these two ones are good options for hybrid vehicles. But if you want your if you want to choose a chemistry for a full electric vehicle, you have the lithium nickel manganese cobalt oxide, for example. Because why? Because you need to be possible to use the fast charging, and also you are gonna give very high power to your e-motor, okay, in order to move the vehicle. So the maximum C rate is 10 C rates, so it's a lot. So is you are gonna be able to use the fast charging. Also, the life cycles are very high, 2000 life cycles. So your battery is gonna be used for a lot of time. Okay. Also, the voltage is very important, no? Because if your nominal voltage is higher, you are gonna need less number of cells in order to build your battery pack. Okay. So now, guys, let's see examples of different electric vehicles and hybrid vehicles, and what kind of chemistry they use in their cathodes for their lithium-ion batteries. Okay, as you can see, the most common is the NMC chemistry and the NCA chemistry. No, so the NMC, that is the lithium nickel manganese cobalt oxide, is the most used for full electric vehicles, because as you can see in the slide before, you have a lot of life cycles. You also have very high C rate, maximum C rate, no? And the lithium nickel cobalt aluminum oxide is very common for hybrid vehicles. Okay, that is and also let's see the different formats for the cells. No, uh, it's gonna depend of the car manufacturer what kind of format of cells they are gonna use. No, we can see the prismatic, the pouch, the cylindrical. No, this is gonna change depending of the car manufacturer. Okay. Also the capacity, as you can see, the highest ones are for full electric vehicles. No, and the also you have well, the cell manufacturers, no, that you can find in the market, no, LG, Panasonic. Well, also now we have uh, CATL, no, BYD also, no? So it's gonna depends of all these characteristics are gonna depend of the car manufacturer.